Congratulations on hitting the end of this chapter where we were learning about static and const members, and we had a chance to look at a few other things. We started out by learning that the regular member variables we have learned about are really tied to objects. So each object you create from the class, it's going to have its own copy of the member variables. It's also going to have its own copies for the functions that are going to work on the member variables that we have in the class object. But we have seen that it is possible to set up members that are associated with the class blueprint itself. For example, we could set up member functions that are tied to the class blueprint. We could also set up member functions that are tied to the class blueprint, and we saw how these things could work. Okay, so to be specific, we saw that you can set up static member variables by prepending the static keyword in front of the member variable. And when you do this, the member variable is associated with the class itself. It is no longer associated with class objects. And when you set up a static member variable like this, you have to remember to initialize that in some CPP file. We have learned about that. And this is the specific syntax you can do to do that. You have to specify the class where the member variable is living. You have to specify its type. And then you're going to initialize that however you want. In this case, we are 0 initializing our static member variable. So this is one way to do this. But we saw that in C++17, it is possible to do this without splitting your member variable into declaration and definition like we have seen before. You could do that all inside the class by marking your static variable as inline. When you do this, the compiler is going to make sure that this is limited to the translation unit in which this is going to show up. And we're going to be learning about inline member variables in more detail in the next chapter, but this should be enough for now, allowing you to declare and initialize your static member variables in one go inside the class definition, and this is really cool. We also saw that we could use the static mechanism to initialize our constants when the constants are really associated with the class object. This is really cool. We can do that, and we don't have to maintain these constants on the outside of the class. This is going to make our code much more manageable. We also had a chance to see that before C++17, it was really tedious to declare and maintain static constants. For example, it was only possible to initialize them in the class declaration if your static member happens to be of int type or some enum type. For other types, you had to split things into the class declaration and put the actual initialization in a CPP file, and we saw that this was really ugly, but if you have to do this, this is the syntax you have to go through. We also had a chance to see that you could set up non-static const member variables, and this is the syntax you have to go through to do this, and we have to split this into declaration and definition, and the definitions have to show up in another CPP file. So for example, we could go in another CPP file and initialize these guys using initializer lists. We saw that if you try to do something like this and not go through initializer lists, you would get a compiler error, because for const member variables, the only way to initialize them is to go through an initializer list like we see here. We moved on and looked at how you could set up member variables of type self. We saw many ways you could set up something problematic that would give you incomplete type errors, but we saw that there are other ways we can get around this by setting up static member variables, for example, or using pointers like we see here. And we saw that you need to be careful about a pointer like this, because if you call the constructor, you would end up with an endless chain of calls to the constructor. And this would be a recipe for a disaster, because you would call the constructor many times and you would basically run out of heap memory. Eventually, your program would crash. We saw an example of this. We also saw that if your member variables are not of self type, you were really free to use your member variables however you want. And the limitations we saw for self types were not there. You could really do whatever you want with your member variables. We moved on and looked at how you can set up static member functions for your classes, and all you had to do was prepend the static keyword in front of the signature for your member function. And the moment you do this, The member functions are going to be associated with the class blueprint. They are not going to be associated with the class object. This had a few consequences, and the big one being that inside the static member function, you're no longer allowed to modify or access the member variables directly because the static member function doesn't know which member variable it's going to access. It's not associated with any class object. You really need to be aware of this. If you need to modify or access the member variables inside the static member function, you will have to pass the parameter of some kind and go through the parameter name and access the member variables. We saw that this was possible. We had a chance to learn about nested classes, and we saw that you could do this, for example, to limit how people create objects of your class and force people to create the class object inside the other class. We saw that this was possible. We then had a chance to zoom in on in-class member initialization. We saw that you can do all these things you see here, and it was even possible to in-class member initialize a custom type like we see integer here, and this was possible. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to zoom in on how you work with multiple files in your C++ program and incorporate and really bring in the knowledge that we have about classes so far. So go ahead and finish up here and meet me there.